Hi everyone, I chose to do Lab 5 on collisions. So the purpose of this lab is to observe and analyze the motion of an object as it collides with another object at rest. And the experimental measurements were calculated using Tracker, and they'll be compared to a computational model. And then the main principles explored in this lab are Newton's second law, the conservation of momentum and kinetic energy, and the idea of elastic and inelastic collisions, where the kinetic energy is conserved in elastic collisions and not conserved in inelastic collisions. Overall, the results from both models were similar but not exact. There was a slight deviation that compounded over time, which led to a difference in values at the end of the time interval. So the system in this experiment are the two bowling balls and the surroundings are nothing. At t equals 0, the first bowling ball had a non-zero initial velocity because it was the one in motion. The second bowling ball was located at that vector 0 and had a velocity of 0 as well. So this is the video I used for Tracker. I just got it off of YouTube. To track the time and position of the bowling balls, I plotted their location on Tracker at each time step. And Tracker compiled the information into a table of time, x, and y values. And then this information was used to create a graph with position and time. So the first bowling ball you can see is the red line, and you can see how it starts out moving and then goes to rest, and then after, like once the collision happens, and then the blue line is the second bowling ball, and you can see it's at rest until the collision when it starts moving. Now for the computational model. So these are the initial conditions. To create the computational model, I created the code in GlowScript to show the position of the two balls over time, as well as a vector representation of the collision. The initial conditions, like the time, position, and velocity, were obtained from Tracker. So this is the first iteration. It was from the start of the bowling ball swinging to its collision point. To code it, I updated the velocity and position of ball 1 and 2. And then the second iteration is similar, except it was from the collision point to the second bowling ball's highest point. And then this is the output of the code. As you can see, you can't see in the video, but basically the vectors kind of represent the collision. And then the graph below is also outputted by the code, and I'm going to talk a bit more about that in the next slide. So these are the two graphs from the data. The one on the left is the experimental data. As you can see, there are some slight discrepancies, but for the most part, both graphs are pretty similar. So some possible errors. While using Tracker, it is very easy to plot a point incorrectly, which would alter the data, and rounding the data could cause discrepancies, and any outside forces will skew the data as well. So that's just important to keep in mind. Now some similarities between the two. The computational model and the experimental model showed how ball 1 was moving at a velocity that was transferred to ball 2 after the collision. Due to the errors mentioned before, the experimental graph showed some discrepancies compared to the computational graph. This is mostly due to outside forces and user error that the computational model didn't account for. What if? So was the momentum conserved during the collision? Yes. The momentum from ball 1 was transferred to ball 2 as shown by the previous graph. And that's it. Thanks for watching.